All right. Welcome to my session about JVM microframeworks. Um, Good to have you here. Let me first introduce myself. So my name is Jaap Coomans. I'm from Tilburg in the Netherlands. That's a city near the south border with Belgium. I'm a Java developer. I've been doing Java since 2002 and professionally since 2006. And I work for a company called Group 9. We're a group of experienced Java developers and architects. Outside work, I'm a husband and a father of two girls. And I love to play board games. And for while playing the board games, I love to drink a nice beer as well. But that's more than enough about me. Let's talk about microframeworks. So mostly when I say the term microframework, the first response is, don't you actually mean microservices framework? And while you can use every micro framework for your microservices, it's not necessarily the same. So I'm actually really talking about micro framework here. So now you may be wondering, then what actually is a micro framework if it's not a microservices framework? Well, let's turn to my favorite source of definitions, that's Wikipedia. Wikipedia says, a microframework is a term used to refer to minimalistic web application frameworks. It is contrasted with full stack frameworks. So, what did we learn here? Well, first of all, not a lot. It must be minimalistic and it must not be a full stack framework. So, good for me. This gives me all the room in this talk to make my own judgments about what is a micro framework and what's not. But also a little scary for me because that makes the landscape really big. But I think we'll manage. So let's look into a little bit of history. Micro frameworks on the JVM started out in 2009. So the first ones to appear were Scalatra and Jaap. Then Redpack joined, Drop Wizard, Spark, Play, Ninja, and then from 2014 on, a lot of new frameworks joined the ranks. Latest ones are from 2018, and that's a little surprising because that means by now, 2019, 20, 21, no new frameworks joined. So that can mean a lot of things, of course. Maybe the pandemic hit and no one wanted to create a new framework. Maybe the micro framework arena is full and everyone is pleased with what they have. I don't know. But I thought it was interesting to see. So what do I have now? It's a list of 32 frameworks I could find. And that's a little too long. That's too much to discuss during this session. So I'll have to weed some out. So the first thing I did is just go over the list and see if there's easy candidates to scrap off. First off is JLHTTP. It has a GPL license, which I don't really like, but that's not the main point. The main point is that it's hosted on a custom hosting platform, whereas all the others are on GitHub. So it was a little bit shady, and that doesn't really help for adoption. So I'm scrapping that off the list. Then next is Jaap. They actually call themselves a set of micro frameworks. And comparing to the other ones here on the list, I would rather call it a set of small libraries myself. Maybe there are some, but it's not a micro framework in the sense that I'm looking for as a web framework. So that's off the list as well. Then next, KHTTP appears to be that project. The Ninja framework is a self-proclaimed full stack framework. And if there's one thing we learned from the Wikipedia definition, that's in contrast with a micro framework. Although it appears on some lists, I had to scratch it off for that reason. Then Play framework. Well, it's a very cool framework, but it's not really micro anymore. It actually is a full stack framework. Quarkus, more or less the same reasoning. It also is a full stack framework. It is micro in terms of startup times, but outside that, it's not really a micro framework. Rapidoid I had to scrap off because of the lack of documentation of the current version. There's some documentation of a previous version, but I just couldn't get it to work. Couldn't work it out. And lastly, Redkill. All the docs are in Chinese. My Chinese is a little rusty, so that doesn't help. Maybe it's an awesome framework, but I just can't tell. You may be wondering, well, I see 32 frameworks, but my favorite framework is missing here. In that case, I just missed out on it for some reason. Please let me know. I'd love to hear about your favorite microframework that's not on the list. So let's see if we can get some order into this. It's still a pretty long list. Let's see if we can maybe categorize them into groups to make it more overseeable. So to give you a little bit of insight into where we're heading, I invented this little opinion-ometer. The upcoming section is mostly factual. So licenses. All these frameworks are open source frameworks. So maybe we can divide them by the license they're using. So let's have a look. First of all, almost all of them use the Apache license, which is a really cool license, both for creators and users. But it's a really big chunk. Then there's a couple with the BSD license, both 2 and 3 clause. Coomans has the MIT license, which is fairly similar to BSD. And then lastly, Jan has LGPL. So this is not really a big differentiator. If you really care about this, there is some room, but this will not determine your choice probably. So next, the programming language. Of course, these are all JVM microframeworks. So in theory, we could use them with every single language that runs on the JVM. But I'm talking about programming languages that are officially supported through the documentation and targeted through the APIs. So obviously on the JVM, the vast majority supports Java. Also, a couple support Kotlin. Ktor, HTTP4K, primarily Kotlin. And then there's a couple that support Kotlin besides Java. There's some more that also support Groovy as a second language. And then finally, maybe no surprise that Scalatra uses Scala. And interestingly enough, I didn't really dive into it, but I wanted to mention it here because it really tickled my interest. Coomans also claims to support Node and Go, which is interesting because it's a micro-profile framework. But the docs say it does. So next, the programming model. What will your code look like if you start developing using this framework? What kind of constructs will you encounter? Well, first of all, as I already mentioned, there's microprofile. You can see there's 4 frameworks using microprofile, which is becoming a more well-known standard nowadays. Then there's quite a bunch, roughly half, that support a programmatic model, and that's mostly using APIs, and it's more declarative in programming. So there's no annotations involved. And you can see here that Helidon supports both microprofile and programmatic, and Helidon does that by actually being 2 frameworks. There's Helidon microprofile, and there's Helidon SE, which supports the programmatic model. Then there are some frameworks that have their own custom annotations. For instance, here, Micronaut has annotations that are very similar to the Spring annotations to make the transition really easy. There's a couple that purely work on JAX-RS, so they're in the same area as the microprofile ones, but not full microprofile. And lastly, Lite4j supports code generation, which is interesting if you ask me. Another interesting thing to look at when you're selecting open source technology is to see which organization is behind it. So roughly half of these frameworks have a company behind it. And that ranges from smaller, less known companies to really big ones like Oracle for Helidon and JetBrains for Cador and the object group for Micronaut. So that's, there's at least someone financially investing in these frameworks. Then to my surprise, there's only one that's backed by a non-profit organization, so Apache in this case for Microwave. And then all the others fall in the category of what I now call community. So there's one committer or a little group of committers that drive the platform, the framework themselves. So from a more technical perspective, we can look at what web engine is supported. So roughly half supports Jetty. Then if we bring in Tomcat, there's some more, and you can immediately see there's quite some frameworks that support both Jetty and Tomcat. And going forward, adding in Undertow, you will see that there's a lot of choice here. Adding in Netty, and to make the Mondrian picture complete, there's some others. Most notable here is Ktor has its own one, CIO, which then is supported by HTTP4K in turn. So this is not really something where you will make your decision on, probably, because many frameworks give you more than one option. So that's enough for the categories. Let's see if we can measure something, because as a wise man once said, to measure is to know. So what can we measure? As you can imagine, I'm going to measure stuff, so the upcoming section is mostly factual again. So my first hunch was to go to Google Trends to get to see where it went over time, a little bit of trending, what's coming, what's going. And while the idea was really nice, it quickly turned out with these set of frameworks that wasn't really an option. And the reason for that is that most of them are pretty small in adoption, and they have names that are not really unique. So Google Trends has a hard time distinguishing between, for instance, the hammock in your backyard and hammock as the framework on your computer. So that was screwing up results pretty badly. Only the 3 to 4 biggest frameworks really stood out and had their own numbers here. So no Google Trends, unfortunately. So what else can we measure? So let's have a look at measures that we can find. Well, first of all, the number of active contributors. How many people are actively contributing to the framework? It gives a little indication of liveliness of the community. And yeah, well, what is an active contributor? So I had to come up with a really arbitrary definition here. I took at least 20 commits in the past 2 years and 1,000 lines of code or more touched in the past 2 years. It's completely arbitrary, but yeah, you'll have to draw the line somewhere here. Then another number that's pretty clear is the number of stars on GitHub. What's not clear, of course, what people mean with giving a star, but well, it will give at least some numbers. Then the number of questions on Stack Overflow, and also the number of followers on Stack Overflow. So if a framework has a tag on Stack Overflow, how many people actively follow that tag? Well, let's have a look at what I found out. So first of all, the number of active contributors. Here you see there's a pretty wide range. Micronaut is the clear winner with 15 active contributors. And there's a couple more that are high scoring. So Helidon with 11, Ktor, Amiria with 5. Then there's some 4, 3, 2, 1. And actually some where I found 0 active contributors. It doesn't mean the projects are dead. They're just below my threshold. that I set. And interesting here is to see that the 4 biggest ones are all backed by a company. So that gives you a little bit of an impression about what money can do to an open source project. So next, the number of stars on GitHub. And here you see an even wider range. So clear winner here is Spark, but Ktor and Drop Result are also doing really well here. There's some in the middle scoring some thousands, but there's also some really low rankers. The lowest here is John with 10 stars. And to give you a little bit of an indication about what it means to have that number of stars, I have an open source repository that has some code examples relating to this talk. I will share the link later. I did this talk twice before. I have 7 stars on that repository. So that at least gives a little bit of an indication of what it means to have 10, 15, 12 stars. Then the number of questions on Stack Overflow. I had to put this on a logarithmic scale to make some of them even visible. So bear that in mind. The clear winner here is Drop Result with almost 2,000 questions. Then the runner-up, Micronaut, with roughly half of that, around 1,000. Then there's Spark and Scalatra and Ktor still scoring a couple of hundreds. And after that, it's all below hundreds. And even quite some that have no questions on Stack Overflow at all. Then looking at the number of followers on Stack Overflow, it may be of no surprise that here again a couple score 0. But here the difference is even bigger. Drop Result again is big. 825 people are apparently actively interested in Drop Result. There's a couple of hundreds for Micronaut, Ktor, and Spark, and then it drops down quickly again. So these are exact numbers. Can we relate them somehow? Well, what I did here is I indexed them all. So for every category, I gave the highest score 100 points, and the rest score relative to that. And then if you join it all in, you can see in this picture that Drop Result is pretty good over a couple of categories. Micronaut is high, Ktor, Spark, Helidon, they're all scoring some decent points somewhere, but there are also a couple that are, almost absent here. And then also interesting, those were the scores as indexed relatively to one another. What if we bring in something more well-known, like Spring Boot? It's not a microframework at all, but it's a well-known framework with a lot of adoption. And that's been around for quite a while. Now, on the very right-hand side, you see Spring Boot. Only in the number of active contributors, it's not keeping up with the highest score. But the rest of the categories, you see some even almost vanish from the picture. So that gives you a little bit of an indicator where this business is at with microframeworks. It's really still pretty much a niche. Okay, so we've had quite some facts. The upcoming section, there's a little bit more room for debate. My own opinion may come in every once in a while. First of all, by selecting this slightly less long list. So based on the numbers that we saw, I scratched some more of the list and ended up with these 15. Note that I listed Helidon twice here because Helidon SE and Helidon Microprofile are actually distinctly different frameworks. And for these, I found some other interesting tool. The link is at the bottom of the screen that at least helps you to give the number of GitHub stars over time. So this might give a little bit of a clue about whether something is on the rise or not. So these are the high rollers. Note that on the left, this goes up to 8, 9K. And in the next picture, I have the low rollers on a different scale. What's clearly visible here is that drop risk is scoring high, but it's been around for a pretty long time, and the curve is flattening, and the same goes for Spark. Really on the rise here is Kador. Looking at the direction that line is going, it's probably going to take over Spark anytime soon as well. So some of the lower rankers, there's quite a lot of fairly flat lines here, but very interesting to see is Armeria is clearly rising steadily over time, but still rising. And Helidon had really almost a vertical start and is still on the rise right now. So these are probably up and coming in the landscape. Now, what can I do with these 15 frameworks? I thought, let's try them out firsthand. And what I did is I created a simple to-do backend implementation for them. If you're not familiar with the to-do backend project, maybe you're familiar with the slightly more well-known to-do MVC project. To-do backend aims at defining a really simple REST-based application to maintain a list of to-do items. And the thought behind this, if we have relatively simple comparable specs, you can implement it easily in multiple technologies. So on the website, you can find all kinds of implementations. What I did, I created my own implementation for these 15 frameworks. So they were all also fairly similar to each other. So what is a to-do backend implementation? It's actually a collection of 6 REST endpoints. It's CRUD and a little extra. Then, of course, there's some JSON serialization involved. And many frameworks offer their own serialization, which is mostly JSON. So for that reason, when a framework leaves the option open to add one myself, I opted for JSON to get a pretty fair comparison across the board. Then an interesting one from the test set of to-do backend is the core support that they're actively checking. So all my implementations also had to have some core support. And I chose for the very minimalistic setup. So there's no database behind it. It's all in memory. I created a little shared library to use across all these implementations and a test set to test them. So what did I find from this? First of all, I measured the size of dependencies in megabytes. So smaller is better. And let's have a look. There's quite a range, but it's steadily going from Armeria at 18.5 megabytes to Spark at roughly more than 4.5. So it's scattered. There's no big winners or big losers here. But this is just the size of the dependencies. What's actually more interesting, in my opinion, is the number of dependencies, because every single dependency carries a little risk in maintenance, security, and you want to have that number as little as possible. And also it will help reducing startup times, of course. Before we go there, I added in the numbers from almost a year ago. So the first time I did this talk was briefly before the pandemic hit us. So that's roughly 15 months ago. And I also did the measurements then. And as you can see, quite some of these dropped, some gained a little bit. There's not a huge difference outside Helidon and HTTP4K. So, going to the number of dependencies. Clear winner, or actually, I should say loser here, is Helidon Microprofile with more than 140 dependencies for this little application alone. In contrast with that, Helidon SE, so more or less the same framework but a different flavor, has 45. So there's roughly 100 dependencies in difference that Microprofile brings in there. And The actual winner with only 16 dependencies is Blade. And yeah, well, as you can see, drop result is a little higher, Cumulus E is a little higher, and the rest is around the same track of 20, 30, 40 dependencies. This too I did last year. So if you look at these numbers, there's some differences, not too big. Halidon microprofile actually improved quite a lot by roughly 20 dependencies. Then we're talking about microframeworks, so not only size is important, but also startup times. What I did, I measured the startup times on my machine. And my machine is a machine with 16 gig of RAM. It has an i7 processor with 4 cores. I'm using Docker Desktop for this. In the current setup, it's with JDK 16, except for Cumulus E, which doesn't support 16 yet. So there I opted for JDK 15. And I took the median of 5 stars. So still fairly arbitrary, but it gives an ID. And you see here that Cumulus EE is at more than 2.5 seconds, the slowest of all. In the same ballpark as Halidon microprofile, and drop versus is slightly below that. Then it drops really to a fair amount below 1 second, with the clear winner Kador at 150 milliseconds. But Javelin, Blade are also scoring pretty well here. And if you compare this to a little more than a year ago, bear in mind that was on JDK 13. So the difference in JDK may very well also be a reason. You see that almost all frameworks really improved quite a lot on this topic. Where even in the previous edition, Kador was the only one that scored that low, and now Blade and Javelin and Spark joined the ranks of Kador. So a lot of improvement has been going on. Maybe because of JDK, maybe because of new framework versions. So in terms of framework versions, this is what happened during the pandemic. On the left, you see the versions I used in January 2020, and on the right, you see the versions I used a couple of days ago in May 21. The green ones is where a major release was done, and mostly that actually meant also following an upgrade guide, and I could really change out some stuff. In some cases, I had to build in custom core support in the previous version, and I could scratch that away right now. Then the two orange ones only have a minor or bug fix upgrade, but as we saw in the previous slide for Blade, that even means a vast increase in startup time. So version numbers are not always telling the whole story. So some more room for debate upcoming, because what I'm about to show is for every framework some code examples. And of course, you can't get around how a framework works, but I did it how I would set it up, and everyone has a little bit of a different flavor, so bear that in mind. So this is the first slide for Ameria, and what you can see here is the main method that starts the server, add some endpoints. These handlers you can add by via Lambda or via instantiating a class, as you can see. And then the endpoints look like this. So these are the annotated Ameria style endpoints. They're fairly similar to what we know from other frameworks. Not a lot of surprises here, but they're custom annotations. So next up, Blade. As you can see here, I needed less code than for Ameria to get the application going. You see similar setup here. And then you have to set up the routes, like in the top here. So I said this route goes to that handler. That's a pattern that you will see a lot, especially with the programmatic ones, where you set up a route and tie that to a handler. And the handler can be a lambda here as well. Here you get a context which includes the request and a response. So everything you do in your handler is around that context. Then drop wizard. Well, some more boilerplate, as we saw with the previous frameworks as well. And an endpoint looks like this. This is not too surprising, of course. It's JSON. I think many of you will know this. Then Helen, the micro profile. The main method looks like this. What I added here, the Hello World application and the To Do application are JSON applications. That's all you have to add, and the rest is regular micro profile. So I have no more slides about that. In contrast with that, there's Helen SE. And what you can see here, there's quite some more fine-grained control I have about starting up. This was actually the only framework that didn't actively log their own startup time, so I had to build in something myself, and that's what you see here. That's most of the deal. If you don't care about that, you can make this even shorter. And then you have an option to set some routing rules. This is similar to what we saw before. You add the route and tie it to a handler. In this case, the handler takes a request and a response. Those are actually the two main flavors looking through all the programmatic frameworks. Some have a context, like we saw with Blade, if I'm not mistaken, and some have a request and a response. Then HTTP4K is a Kotlin framework. So what you're looking at right now is Kotlin. And here, you can see more or less the same patterns as you saw before. We're setting up routes, mapping a path to a controller. And the controllers are lambdas as well here. I had to add in a filter for the course. And this is an example of one of those handlers that's behind it. Here you can see the request comes in as a parameter and it returns a response, which is a slight different flavor. I think that's fairly nice. Then Javelin. I'm offering an example in Java here, but Javelin, as the name suggests, which is a contraction between Java and Kotlin, also supports Kotlin. So then it would look slightly different, but not too different. Simple setup with some routes and some more routing in here, so you can nest that. What I have here is the get all endpoint. So Javelin has a context object again that wraps the request and the response. You're going to Juby. Here you have more static nature. So there's the static run app method that takes some arguments and requires a lambda. There you can do the setup, you can add the handlers. I had to do something about the startup time here as well, by the way. And then a handler looks like this. So you see a pattern emerging. The handlers mostly are either JSON or their request response or a context object. Then Kdor is really different than most others. And the biggest difference between Ktor and HTTP4K is that this is really built around Kotlin. So if you're really into Kotlin, you know all the language constructs, and you're not, like I am, doing Java in Kotlin, then this really is the framework for you. So this is one of the handlers. You see, it really looks different than the Java ones, because it's kind of a DSL-like solution, and they created for the Microframework. Then Cumulus UI, that's microprofile again, so nothing really new. Micronaut, it has a really simple setup, as you can see there. And then for the rest, it feels like Spring in terms of the annotations it does. It doesn't rely on reflection like Spring, and it has its own annotation. But if you're used to Spring, then Micronaut will feel very familiar. So one of the endpoints here, also no big surprises here. The Minigex, that's one of the really smaller interesting ones that are around. So you have to register everything here. So I had to register JSON feature, course filter, but also the controllers. So this is the setup and the start of the server. Oh, and that was all. And for Pippo, this is the main setup. So a really simple setup where I create a server, map to a port, some routing like we saw before, and then we can start the server. Pippo again works with a context object, the route context. And Redpack, really simple main method, just one line, but of course you need to pass in something via lambda. So that's below. That's the initialization where you say what you want to add in terms of modules and handlers. This is the path mapping. This was, for me, rather difficult to do. And I think that has to do because Redpack is more aimed at Groovy and not so much at Java. And I'm not really good at Groovy. So I try to smash it into the Java structure. As you can see, this is not really optimal. So maybe if you're doing this with Groovy, Redpack is giving way better results. Then lastly, Spark, of which Javelin that we encountered before is a fork. And you can see really simple low-level setup, some static helper methods for that. And here's, for instance, the JSON support and the routing. So in the routing, you don't only define the route and the handler, but if you need a JSON transformer here, you have to add that in as well. So, well, it's really minimalistic, but it accounts for quite some repetition in some places. Okay, so that's the code examples. Upcoming section, opinion alert. This is purely my opinion. So the winners, in my opinion, I'll also tell you why. First of all, Javelin. It has to do with, for one, the numbers are really good. It's giving good performance. It has quite some adoption. It supports both Java and Kotlin, and I personally like the programmatic model. So this is just a personal favorite. Then next one, Ktor. As you saw, it's really, this is Kotlin to the bone. So if you're into Kotlin and you want to have a Kotlin framework, then Ktor is your thing. And besides that, it really had good numbers overall. Then Dropviz, well, I just can't get around that. You saw in the numbers section how much activity is around this framework. People are actively using it. You can find a lot of documentation about it, a lot of other resources. So it seems to be a very solid choice. Then if you're into Spring, but want something else, then Micronaut may be a very good choice to get started. It will feel very familiar, yet it does ahead of time compilation instead of reflection. And lastly, Helidon SE. Helidon micro profile didn't really appeal to me, but the programmatic model of SE was pretty nice. And well, there's Oracle behind this, so you might like Oracle or not. It's a big company that can invest a lot, so that will probably give Helidon a good future. Some personal takeaways that I had from doing this exercise, I'd also like to share with you. First of all, I learned that Maven archetypes are still pretty much in use. I thought they were dead and buried, but while going through the getting started guides of all these frameworks, so I did these 15, but I looked at others as well. A lot of guys start with just run this archetype. So that was an eye-opener for me. And yeah, well, a conclusion we can make, especially based on the numbers section, it's not just micro as in size and startup times, but it's also micro as in adoption. A lot of these frameworks are really cool from a technical perspective. They're smart, they're small, but they're not too big in terms of adoption. So there's a few ones that you could take and say to your employer, yeah, let's do a project with this. But I think there's also a lot that are more geared for, well, your home prep project. So for that reason, think before you choose. Really take a careful look at what you're going into. It may be nice from a technical perspective, but maybe from a long-term support perspective or security, you should have a second look. And with that, we've reached the end of the talk. Now, there's time for questions. Before we go there, please reach out to me if you have some suggestions, remarks, or more questions. And you can get the code of all the 15 frameworks I did on GitHub. The link is below. Thanks for your attention. There's no questions in Q&A, I see. Okay, then please find me, for instance, via Twitter if some questions do pop up later. Have a lot of fun with the rest of the conference. Thanks.